So the first way that we're going to learn how to solve matrices in 6.3 is solving them using inverses. All right, so you can use the inverse of a matrix. Now that we learned how to find inverses, you could use the inverse of a matrix to solve for the variables in a matrix. So for example, when we had, x, y, z, and you were using Gaussian elimination to find the x and the y and the z, you could also use inverses to find them. Okay, well, how do we do that? What you do is you rewrite the system in matrix form. Okay, so it's A times X equals B, and I'll show you how to do that. And that's basically, it's going to have three matrices. Okay, an A matrix, an X matrix, and a B matrix. And then we have to find A inverse. All right, and once we find A inverse, we are then going to multiply A inverse times B. So let's just think about why it is that we do that. Well, here's the reason why we do that. In algebra, when you have to solve something like this, 3x is equal to 7, right? What do you do to solve this? Divide by 3. Divide both sides by 3. But what exactly is dividing by 3? You're multiplying by the multiplicative inverse. 1 over 3, 1 over 3, right? So if I have a matrix A times another matrix X equals another matrix B, I can't divide both sides by matrix A. Dividing by a matrix is not a thing. Instead, I multiply by A inverse. So what I say is X is equal to A inverse times B. Okay? So that's what we're going to do. So it's just like dividing both sides by a matrix, but don't ever get caught saying that out loud, okay? Okay. So here we go. Use an inverse matrix to solve the system of equations if possible. It's not going to be possible in the case where the matrix is singular, meaning like it doesn't have an inverse, okay? All right, so first we write the coefficient matrix. The coefficients are just 2, -3, -3, and 5. This is what we call matrix A. Then we write the variables matrix. This is what we call matrix X. Now that we know how to multiply, right? Let's say you were going to multiply row 1, column 1. Then what would you get? 2x minus 3y. 2x minus 3y. Do you see where, okay? You're just undoing the multiplication sort of, okay? Now that's going to equal the coefficients, the constants, -1, 3. And we call that the B matrix, all right? Now what we have to do is find the inverse of A and then multiply A inverse times B. So let's find inverse of A. To do that, first I need determinant of A. And that's going to be 10 minus -9. That was right. Right? So that's going to be 19.
No, it's plus 9.
Oh, yeah, 10 minus. That's much better. Okay? So A inverse is 1 over 1 times, I switch the places of the main diagonal, flip the signs of the second diagonal. So that's my matrix. That's A inverse. So now, X, the matrix XY is going to equal to A inverse 5, 3, 3, 2 times B. Okay, and this we can multiply. All right, I have a 2 by 2 and a 2 by 1, so I'm going to get a 2 by 1, okay? All right, so first row, first column, row 1, column 1, I get -5 plus 9, that's a 4. Row 2, column 1, negative 3 plus 6, that's a 3. So what have I solved for here? I've solved for the matrix X and Y. So my solution then is 4, 3. Now, back when you were in like the 8th grade, right? And you learned how to solve these using elimination and substitution, what did you do? You would multiply that by 3, you would multiply that by 2, you would add them, blah, 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 you would get something, and then you would get x equals 4, y equals 3. Same situation.
Can we do that?
No.
Can you do this with 3 variables?
That's the whole point, is that you could do it with 3, 5, 9.
So with the x, y,
You could do it with 15 variables. Okay, this is like a general. Okay, so and obviously when you have 2 variables, yeah, it's easier to do pre-algebra. Okay, but when you do have 4, 5, 15 variables, oh my, that is tough. Okay. All right, so that was one way, using inverses. Okay. And now, how about solving systems using Cramer's rule? So now this is the second way in this lesson that we're going to solve matrices. So far we will have learned 3. Gaussian elimination, inverses, and Cramer's rule. Gauss-Jordan and Gaussian I consider to be like the same, because it's the same process, you just go a little bit further. Okay? Cramer's rule is another method of solving matrices using determinants only. And I remember like when I learned this the first time I learned this, I loved it so much. And I still do, I think. Okay. So the book, right, again, that's the book's word. Those are the book's words. And then here I say the same thing a little bit better. To solve a system using Cramer's rule, here's what you do. You find the determinant of the coefficient matrix. We just learned how to write the coefficient matrix. You replace each column by the constants column to find the determinants A1, A2, and so on. We'll do one. Divide each of the determinants in step 2 by determinant A. All right, so here it is. Take a look at this system of equations. Notice you don't have x and y, you have x1 and x2. All right, when it comes to variables, okay, again, matrices are built really to solve systems with many variables, okay, like 10, 15, 30. And, you know, when you do have 30 variables, you run out of letters in the alphabet, right? So another way to name these variables is x1, x2, x3, x4, x30, okay? So here, I just wanted to get you exposed to this. The book also uses this in some of their problems, this method. It's just like having x and y, or a and b, or r and t, all right? Technically, the variables, you could call them whatever you want. It could be like happy face and banana, right? It doesn't have to be x and y at all. It could be theta and lambda, okay? All right, so we're going to do the same thing. So A is the coefficient matrix, and that's going to be 4, -5, -3, 2. Okay? And can we find the determinant of A? That's going to be what? -7. It's 8 plus, it's 8 minus 15. Okay. So now what we're going to do is we're going to write the matrix AX1. And the matrix AX1 is this. So if you remember, this is going to be the X1 column, and that's the X2 column always, right? AX1, right, what you have to do is you have to replace the first column by the constants. So you see these constants, they go in the first column, and then the second column remains unchanged. Okay? So now let's find this determinant. So for a matrix AX1, you have to replace the first column, that's the X1 column, by the constants. Okay? And now we find the determinant. So that's going to be how much? How much? 42 sounds good. Now let's do AX2. This time, the X2 column is going to be replaced by the constants. And then the X1 column is just whatever it was in the original. And what did we get for determinant for AX2? (28 times 4 minus 3 times 49). Negative 35 sounds good to me. Now comes the part about finding the actual variables. So x1, all right, is going to be ax1 over determinant of a. So 42 over negative 7. And that's negative 6. And then x2 is going to be ax2 over determinant of a. Negative 35 over negative 7. X2 is equal to 5. So finally, my solution is negative 6, positive 5. Okay? So find determinants of the respective matrices. And then it's determinant of each matrix divided by original determinant. Huh? This is so much fun because you just get to do like determinant. You don't touch the rows. You don't touch the nothing. Okay? Here, let's do this one. Let's do this one by Kramer's rule. So here we have matrix A is going to be 0, 1, 4, right? And then, what is it? Oh, I know. Here we go. Is that right? That's the A matrix? Okay. Now let's just write the AX matrix. Yeah, hang on. Just give me a second. AX matrix, it's going to be, the first row is going to be negative 1, negative 18, 7. And then 1, negative 2, 0, 4, 1, minus 4. Okay? And then the AY matrix, you're going to replace the second row, the second column by negative 1, negative 18, 7. And we get 4, 1, negative 4, 0, 2, 1. And then AZ, 0, 2, 1, 1 minus 2, 0, negative 1, negative 18, 7. Okay? All right. So let's go on our calculators. Yeah, if it's on a calculator section especially, don't do it by hand. Okay? All right. So, second matrix. All right, we're going to edit that first one. It's a 3 by 3. So let me put in my matrix. 0, 1, 4, 2, minus 2, 1, 1, 0, 0, minus 4. Okay? All right, so what I'm going to do now, second quit. Look, second matrix, math, determinant. Second matrix, press enter to select A, enter. Right? So the determinant of A is 17. All right, now look at how I do number 2. So second matrix again, I'm going to edit. Oh, I'm pressing the wrong button. All right, so I'm going to edit number 1. And all I'm going to do here is edit that first column. So just do -1, down arrow, -18, down arrow, 7, enter. Okay, now look, this part, I want you guys to watch what I'm going to do. Second quit. Don't type determinant again. Just press enter, and it'll now find the determinant. Like, it'll do the same operation for the new matrix. You see that? So the determinant is now -17. Okay? And with this, now let's do the other row. Isn't that so much fun? It may or may not be. If it's not, you have to do it by hand. Okay, so here we go. I just modified that matrix. I do second quit. Just press enter, and you get the determinant for the new one. Right, and then the last one. I'm going to stop this for now. All right, so determinant of the last matrix is -34. So now, x is just -17 over 17, which is 1. Y is 119 over 17, which is how much? What's y? 7. And z is how much? -2. Right? So the answer is -1, 7, -2. All right? Okay? So there we go. It's so much cleaner, you have to admit, than, doing some of the other stuff. There is less room for error. Exactly. Yeah. And sometimes you do get decimals, but, No. Okay. So here we go. Same thing here. Okay. So that's... Say that again? Right. The determinant of A here is 0. So it's no solution. And look, even if you solved it like algebra 1 ways, right? You would get 12x minus 9y is equal to -5. And then if you divide this by 3, 12x minus 9y is equal to 33. And clearly you're going to get no solution there, right? Because if you subtract those two, you're going to get 0 equals -38, which is no solution. You see that? So you can figure out from there that it's no solution. Okay, so these people are so these people are planning an event for 400 guests. Yeah. And the guests can choose one of 3 options for dessert below. The chef must spend 5 minutes on each pie, 8 minutes on each trifle, and 12 minutes on each cheesecake. The total cost of the desserts was $11.70, and the chef spends exactly 45 hours preparing them. Use Kramer's rule to determine how many servings of each dessert are supposed to be prepared. Okay, so they're gonna distribute them by servings, and there are 400 guests total. So if P is the number of servings for the pie, and T is the number of servings for the trifle, and C for the cheesecake, then if we were supposed to accommodate 400 guests, then together we need to have 400 servings of these, right? Meaning P plus T plus C must equal 400. And we need to get 2 more equations. And when you weren't looking, I color-coded the information there. So all the blue there is the time spent on, total and each of them. So he spent 5 minutes on each pie, 8 on each, trifle, and 12 on each cheesecake for a total of how many minutes? 2,700 minutes of his life spent on this. 45 hours, 45 hours. He's getting paid a pretty penny, I'm hoping. And now, the cost, right? The cost, these are the costs for each serving. So, $3. So $3 for the pie, and $2.50 for the trifle, and $4 for the cheesecake are going to add up to $1,170. And now we have ourselves a matrix. So the A matrix is 1, 1, 1, 5, 8, 12, 3, 2.5, and 4. The AP matrix is, the first row will be the first column will be 400, 2,703, and then 1, 8, 2.5, 1, 12, and 4. It's not 3, it's 1170. Okay. AT will be 153, 400, 2700, 1170, 112, 4, and then AC will be what? 153, 182.5, 112, and 4. Okay, so now here's what we're going to do. We need to find the determinants of all of these. Let me stop this for a second and we'll come back. Determinant of A, negative 6.5, AP. AT. And AC. 260. Now, so P then is 1,430 over 6.5. Yes, they're both negative. I'm doing away with the negatives.
I have my rows different, so I got negative for all of them.
That's fine. Oh. Oh.
So it would be positive.
It would be positive. Then all of these would be positive. Yeah. He had his rows different. Huh?
The solutions come out the same, but since I said that.
The solutions will be positive. So how much did we get for P? Huh? 220. And for T, 910 over 6.5, how much is that? How much? Okay, and now look, we didn't even have to calculate the determinant for C, because, I would be fine with P plus T plus C is equal to 400, right? So how much is C? So then, 220 pi, 140 trifle, 60. Yes, because this is no, because this is a, whatchamacallit, it's a, yeah. 40. Okay? All right. So this will be due next period.